Hello everybody, Chris here, and in this video I want to show you how we can take characters that already have animations imported into Godot. So in this case I'm using an animated sprite 2D, and all of the animations were imported using a sprite wizard in the previous video. And we're going to take this and add Limbo AI in order to control the character's states as well as the animations using a finite state machine. So for player characters, I think a finite state machine makes a lot of sense because as you press keys, it's going to switch between specific states, and in those states, the character has specific abilities. But for other characters like enemies, we might use a behavior tree since we need to control the state through code-based decision making. So we can customize that in a flexible way using a behavior tree and its resource editor. So that might be the next video, but for this one, we're going to start with the finite state machine for the player character. So in both of those cases, the plugin I'm using in order to do that is Limbo AI. So we can get Limbo AI from the asset lib. If we go over here and we just type in Limbo, it should be one of the first that pop up. So right now I'm editing on 4.4-7. So I'm going to use the newest version, which is the one for Godot 4.3. As far as I've seen, it still works just fine. I'm going to download this into the project. Now inside of here, there's the add-on itself. There's also demo files. I don't need the demo for this video, but you could go ahead and check those out if you need some other examples. So what I'm going to do to disable the demo from being installed is click over here on the left where we have this arrow. And then I'm going to minimize this Limbo AI and uncheck demo, which is going to uncheck everything in the subdirectories as well. So we install this to the project. Now, even though it goes in the add-ons folder, you don't actually need to enable it as an add-on. So if you go to project settings, plugins, you'll see there's nothing there. That's okay. What you should see though is a new tab pops up to the right of asset lib up here. So this section is here for creating behavior trees, which sets up the logic for controlling how an enemy might operate in your game. But for a state machine, instead, what we actually add is a new type of node to our character scene. So I'm going to right click on my Captain Clown nose and go to add child node. And I'm going to search for Limbo HSM, which is Hierarchical State Machine. So we add that in. And so the state machine allows you to switch between various states. The first one on the list becomes the default states. And through code, you can set what the conditions for switching from one state to another are and how a character would operate inside of those states. So in a regular node script, you have process functions that run all of the time. But for a state machine node, you'll have a specific update function which only runs while the character is actually within that state. And that's how you can make it so that certain code only operates when it's in the appropriate state. That's really handy because let's say your character's in the air state, you might not want it to be able to do a ground swing attack. So you would not have that functionality enabled up here. But when it's in a ground state, you could allow it to do a ground swing. Anyway, to get started, we're going to want to right click on the state machine node and add a child node. And we're going to be looking for Limbo state. So right there, just add a Limbo state. I'm going to rename this to be idle state. And we need to attach a script to it so that it actually has code to execute. So the state node itself doesn't really do anything. It's just a template that we build from. So I'm going to right click on the idle state, attach a script, and we can just put this in player/idlestate.gd, inherits from Limbo state. That's good, great. And then this will be the idle state for the player character. Okay, now in order to make sure that this state machine is actually operating as soon as we launch the character, I'm going to actually add a script to this as well. So let's right click here and attach a script extending from HSM state machine, and let's create. And this will be the state machine for the player character. So in order for the state machine to actually run, you need to tell it what the character it's operating on is so that that character can be passed into the other states as the agent. So I'm going to do an export var here, and I'm going to put in a character that we want to use. So for now, this could just be a character body 2D. So that's going to be like our root up here. And we want to assign this in the inspector. So when you save the script, character should be able to be assigned as the Captain Clown nose if you're working from the same template as I am. And by the way, the before and after for the projects, I'm going to have those on Ko-Fi and Patreon down below as well. So you can use that to follow along if you're not already. And then on ready for the state machine, I want to initialize it. So initialize is already a function we can call, and we need to tell it what the agent is. You can see that this can be any node, but we're building a state machine for a character, so it makes sense to use the character body 2D here. So we start this machine, and the character is the agent that the machine is using. I think you also need to set it to active. So just in case, I'll say set active true. That might be unnecessary. I think Initialize might already do that, but just in case, that should have it set up. Okay, so what this is going to do now is it's going to default the idle state to be the one that this is operating in. In order to see what state the character state machine is actually running, I'm going to create a label above the character for debug purposes. So let's right click on the Captain Clown nose and add in a label. And this label is going to be, let's call it state label, because it will display the current state. I'll right click here, attach a script. Okay, create that. Shows the current state of the state machine as text. Okay, so I want to reference the state machine. So I'm going to say export var, and we can say LimboHSM, just any state machine from Limbo. So this is going to be of type LimboHSM. And what I'm going to want to do is have the setter function connect to a signal from the state machine so that I can easily read whenever the state changes on the state machine. So I don't need to create a process function and just grab the state on every single frame. That's pretty inefficient. What I can do instead is add a colon here and do set values. So we're creating a setter for the property. And I'm going to disconnect from the old LimboHSM if one exists. So if LimboHSM does not equal null, as in it's already been set to something, then I'm going to disconnect from its active state changed signal. So LimboHSM.ActiveStateChanged.disconnect, and we're going to put a callable function in here. We haven't created it yet, but I'll call it onActiveStateChanged. I'll zoom in a bit here as well. Okay, and after disconnecting from the old one, we want to set the state machine to the new value. So basically when the setter runs, we still want to make sure that the property actually receives the value here. That's important. And then I can just copy this code down here and change disconnect to connect, because now the new one has been set, so we want to connect to it. And then down here at the bottom, function on active state changed. So this callback is going to receive two parameters, which is the current limbo state and the previous limbo state. We're not going to use the previous one in this function, so I'm going to underscore it, underscore previous of type limbo state. So the only thing I need to do here is to say that the text of this label is equal to current.name. So the name of the state, which we just entered, is going to show up here in the state label. Now, also, when we set up the new state machine, we do want to make sure that this is initially set at least. So I'll say right after setting a new one that's not null here, we'll get the current state, var current state equals LimboHSM.getActiveState. And then we'll say if current state is not null, basically, then we'll say the text is equal to the current state dot name. Okay, this means on initial set, we're going to have, so this means that on the initial set of the state machine, we grab the name, we set that to the text, and every time it changes, we're going to update the text there as well. So now we just need to assign the state machine in the top right, Limbo state machine, save that. So now we can go ahead and hit play, and we'll see idle state showing down here. So we know what state the state machine's in, and that is a helpful bit of debug information. With the state label, though, I'm going to hit W to go into move mode. I'm going to move this up here above the character, right around there. And now if we hit play, well, we'll see the state shows above the character. That's just a personal preference. Now, the idle state doesn't really do anything right now, but what I want these states to do is play a certain animation when the character enters the state. So that'll be handy for controlling the animated sprite, essentially. So in order to do that, first I need to reference the animated sprite somewhere within the idle state, either through the Blackboard, which we really haven't talked about yet, or we can set a variable on the agent, which I think for this case actually makes a lot of sense. So in the root, we already have this little script here. It's basically the default character body 2D controller script. That's like a built-in template for Godot 4. I just changed a little bit here in the previous video, I believe. But let's add in a reference to the sprite. So if we do @export var sprite, animated sprite 2D, And this doesn't necessarily have to be an animated sprite 2D. You could also mostly make this work with a regular sprite 2D node as well. They just are set up a little differently. An animated sprite 2D, the animations are stored in the sprite, but with a sprite 2D node, you need an animation player, which is a little more complicated, but not too hard to set up. Okay, anyway, we have the reference to the sprite on the player script. So we assign that animated sprite 2D. And remember that we're setting the character body 2D node as the agent for the state machine. So if I was to open up idle state or another state, I could reference the agent.sprite, and I'd be able to grab the character body 2D's sprite node. That'll only work if the script actually has a sprite property, by the way. So just be careful about that. But what I want to do is actually make a extended script from Limbo state, so that when we create the move state and any other state, they can all have a on-enter state animation playing. Okay, so in my file system, I'm going to go and do characters, and let's right-click here, create a new script. This is going to extend Limbo state, and I'll call this character state.gd. If I can type. Okay, great. Let's open that up. And this will be class name character state. And now I can put in the logic needed for setting a default animation up whenever we enter a state. Okay, so first off, I need to know the name of the animation. So I'll do a @export var animation name. This should be a string name, or a string works fine too. So now that we have the animation name, we can implement the enter function. So function underscore enter. When a Limbo state is entered, as in the state machine selects this state as the active state, then we can have it do certain things. So we're going to get the agent and then the sprite, and we want the sprite to play the animation name. So that's really all we have to do to tell it to start playing the animation. Okay, so now with that, we want to go back to idle state and make this extend character state and hit save. Now we'll get the property for animation name. So in my character, the animation I want to play for idle is going to be idle with sword. So idle space S. So if I go to idle state and I type in idle S, okay, and I save it and hit play, then we'll get the animation to play. Okay, now we want to be able to control movement and switching to a move state where it actually plays the move animation instead. So what I could do is create another character state here. So if I right click, add a character state, which is that custom class name we just created. And then I rename this to, let's say, move state, and let's right click, extend this to a move state.gd saved in the player folder. Then I'll save that there. I'll comment move state for player character. And then for the animation name, we'll put this as, I think it's move. I think it was move with S, but let me check the sprite. Maybe it's run S. Yeah, run S. Okay, so run S. Okay, so now there's two states here. One that's going to play run S, one that's going to play idle S, but there's no way to switch from idle to move. So we need to basically get the input from the player, save that to a variable that we are referencing inside of our state machine. So we could put that on the Blackboard, for instance, and then use that input to determine, first off, that we're moving, apply the movement to the character, and then we can transition based on the velocity of our character between move if we're moving and idle if we're sitting in the same place. Okay, so first off, for grabbing the player input, if I jump into the script for Captain Clown Nose, we can see that it's already grabbing the input here. So we have the jump just pressed, and we have the get access on move left and move right for the player's input. That's only being stored locally for this function, and then it's cast aside. But what we actually need to do is to tell the idle and move states about this information. Okay, so what we need to do is to take this direction and set it onto the Blackboard for the state machine so that the states can use that for determining how they should move and if they should change states, essentially. So the Blackboard, you can just think of that as a big dictionary of various information that is shared across LimboAI in the state machines or your behavior trees so that your states can read and access it. And you can also set information to it from outside of the state machine itself. So just a dictionary for saving and reading information from. Okay, Now, in this case, I don't particularly like that the input and the movement logic have been put in the same area, and I kind of want to separate that from the root node as well. So I'm going to right click on Captain Clown Nose. I'm going to add a child for a node, and this node I'm going to rename it to player input. So we're going to attach a script to here, and this can just go in player input. If we like, we can give it a class name as well, player input. And so this script is going to read from the player's input and assign the values to the Blackboard so that other scripts, namely the states, can read from it and operate as they need. So this means I'm going to take the logic out of here, especially this bit right here, and post that in here. So we'll have a process function, because we're going to read this on every frame. We do want to know if nothing's being pressed, so we don't necessarily do the input function. We want to update this on every frame. So var direction is equal to input get access. So this is the left key, and then this is the right key. So A and D on the keyboard. Don't need that little semicolon there, I think. But why we're getting the error is we're not referencing the player actions resource in here. So I will put that in at export var player actions, and this would be player actions. Okay, and we can just quick load that on the side from the already existing resource, which you can see defined move left, move right, and jump. Okay, so the input direction, I'm actually going to get that as a vector now. So we're going to also add in move up and move down actions to both player actions and the input map. We're still going to jump with the spacebar, but I just want to know basically if the player is pressing up or down as well. Might be useful in the future. So if you want to do that, go to the input map on project settings and do move up, move down, and then move down. Add in W for up, S for down. Okay, now we can go in here and change this from get access to get vector. So instead of returning a float, it's now going to return a vector2, which is just a x, y float values. And we want move up as the negative here. So player actions dot move up. Haven't defined that string yet, but we will in a second. Player actions dot move down. Okay, now we can go into player actions. If we right click here, look up symbol. So let's set those values as well. Move up, string name. It's going to be move up, at export var move down, string name, move down. So if I haven't explained this before, the whole idea of this player actions resource is that I'm just keeping basically a list of all the strings that I would be using for action names within the game. So if a bunch of different scripts are using these action names, then I can keep the name consistent by basically having one shared resource here to hold all of the actions. Also, it would be handy when you're editing, let's say, game settings in game, that you could update the player actions and then have one script for saving and loading those to and from a file if you need to. Okay, so essentially shared names for import map actions relevant to the player character controls. Okay, and let's go back to player import, a little over here on the left. So we get the vector from move left, move right, move up, and move down. Okay, so now we're getting that vector2, we're saving it to direction, but we don't really need it as a local variable here. We actually want it script-wide, and we want to update the Blackboard for the state machine. So let's get a reference to the Blackboard. In order to do that, you actually need to reference the state machine, and then on load, you get the Blackboard from the state machine because the Blackboard is created after the game starts, not right now in the editor. So we do a export var LimboHSM. So I'll type LimboHSM, of course. I'll assign that in the inspector. Okay, and then we'll do var Blackboard. I'll type Blackboard, and when the script is ready, then we're going to get the Blackboard from the LimboHSM.Blackboard. Okay, so now those should be referencing the same thing. And once that's set, then you can take this direction and you can set it to the Blackboard whenever you update process. So I'm going to also make this a local property. So var input direction, which is a vector2, and then I'm going to make this actually set down here. So instead of var direction, it's just input direction. So now we're updating the script property. Okay. And from here, there's a couple ways you can handle it. You could do blackboard.setVar, the var name, which we could say is like direction, and then the value is import direction. That would be fine. Another way you can change it is that whenever you update input direction, you just automatically set the Blackboard value. So you could do that with a setter, doing the same thing, set var. Or after you grab the Blackboard, you can do blackboard.bind var to property. So the var we are binding, as in creating a synchronization between what it stores on the Blackboard and what's stored in this local script, will be, let's just say, direction. And then the object is self. The property is input direction. And then we'll have this create the variable inside of the Blackboard automatically by setting this to true. Okay, so this should make it so that whenever this is set and whenever the Blackboard var is set, that they will synchronize with each other. So one way to prove that that's actually working would be to say prints blackboard.getVar direction. Okay, so let's hit play, check output. Okay, and I'm going to move around. Okay, and you can see that it's actually printing the X input here. So the Y is nothing until I press W and S. But yeah, you can see that it's actually grabbing the value there. And it's updating whenever input direction sets. So that's handy. We can get rid of this debug information. And what I might want to do is also create a list of names that are going to be used across Blackboards in the game. So just keeping the variable names consistent. So I'll create a new file. I'll call it BBNames for Blackboard names. So let's say in characters, I'll right click, create a script. This will be BB_names, create. I'll open it up. It does not extend node. This is just going to be a class name, BBNames, and it's going to be a bunch of static variables. So kind of like with the player actions, but this is more of global because they're all static. So you don't actually need to reference a resource or a node. You just reference the class name and you can pull whatever the string name is. So static var, let's say direction var. It's going to be a string name and it's equal to direction. Okay, now that that's saved, I can go into the player input and I can replace this with bbnames.directionVar. And now we have one variable that we'll just share that name across anything that uses the Blackboard. Once again, not required, just reduces the amount of strings you have to change all of the names of if you update it anywhere else. Okay, so we have the move direction, and it's being saved onto the Blackboard and the direction property. If we want, we can go to LimboHSM and we can start creating our Blackboard plan. So if I create a new Blackboard plan here, this will automatically be inherited by the idle state and the move state, so they'll just share the same Blackboard unless you overwrite them with their own Blackboard plan. But here I want to manage this, and I'll add in a variable. I'll just say direction of type vector2. The direction the character is trying to move. So if I hit OK there, then that basically puts in the property that this is automatically creating. So if I want, I can change this to false now, and then it will automatically create that variable. In fact, I think it might error out if we don't have this, but we should be able to hit play and it should still work fine. Okay. Now on our root script, the Captain Clown knows, we no longer need to get this direction. What we need to do is just cut this out, and we'll take the velocity setting in the move and slide, and we'll put that out to our character states. So I'm going to open up the idle state here, and I'm going to go deeper into the character state, right click, look up symbol, and I'm going to create a function here called move. And this can, let's say, return the velocity or something. So I'll just say returns a vector2 with the arrow here. And we're going to take the direction and we're going to use that in order to determine how fast the character should move whenever we call this move function. I just want this to be able to be shared by all of the character states if they are going to allow movement. So the idle can call this and the move can call this. And so we just put that one layer up on character state. Okay, so first we need to grab the direction from the Blackboard. So var direction is going to be equal to blackboard.getVar. And remember, we have that BBNames file. So BBNames.direction. So we're sure that the name is the same because it's stored as that static variable. And once we have the direction, we can check if the direction is not 0, basically. So that's what this does. Checks that the input direction is not 0. Okay, so this is actually a vector here. We're going to want to change this bit a little bit. So we're going to want to make sure that the input.x is not 0. So instead of if direction, we'll say if, I'm going to type in approx here. Yeah, if 0 approx on the direction.x, so the x is a float of the vector, and we want to make sure this is not approximately 0. Then we're going to set the velocity x on the character body. So that's actually going to be the agent.velocity x. It's going to be equal to the direction times the player stats run speed. So we actually need to reference the stats of the character as well. So let's see, if I click on my root, I have the player stats here. So if I right click in here, it's just a resource. All of our characters are probably going to have a run speed and maybe even a jump velocity. So we can also make that a parent class of character stats if we want. So I might right click on characters, create a new script resource. I'll call it character stats. This will extend resource. And then I'll take run speed, put that here. Class name character stats. So if I use this as the parent class, then player stats can just inherit that. So let's go to player stats, and this will extend character stats now. And we no longer need run speed here because that's already set in character stats. Okay, so now go back to character state.gd. I know that was a bit of jumping around. And we should be able to get the character stats from the agent because we're going to say any of these characters actually have their own stats. So on enter, we'll say var character stats, saved up here, and then we'll say character stats equals agent.stats. Okay, so we get the character stats and save it there. And now we can reference that down here. So we'll say character stats.run speed, and then character stats.run speed as well for down there. And then this just needs to be agent.velocity x. So remember, in the limbo state, this is the logic that is going to control character, but the character is still that character body 2D, which we're using as the agent. If you wanted, if it actually makes it a little bit more clear as well, what you could do is say var character of type character body 2D, and just whenever these scripts are entered, we can do character equals agent as character body 2D. It technically automatically already converts, but I think this just makes it a little bit more clear what's happening. So casting the agent as a character body 2D, and then from there, when you do, let's say, character.velocity, you'd actually be able to see all of the properties that character body 2D would have. Otherwise, we're just kind of assuming here that the agent is a character body 2D. And while that will technically work, maybe it's a little bit more clear if it's like this, character.velocity.x. Okay, and then here we want to change direction to direction.x. Remember, we're working with a vector 2 now, not the float that is just x. And over here, let's see, velocity is not defined in the scope. So we need the character.velocity. So we need the character.velocity.x. So we're taking the character's velocity, we're making it approach 0, and we're using the run speed to determine how much we move towards that 0 from the current velocity. Okay, and then it's not the script that's move and sliding, it's the character body, so character.move and slide. And that is basically going to be our move function. The last thing we need to do is return the current velocity, so return character.velocity. And now we have the ability to do ground movement from any character state. Okay, so stop the current execution. Okay, so we can take this function now, go into the idle state, and what we're going to say here is var underscore update. So instead of process, our state is going to use update, which is specific to the limbo states. Update only runs when the state machine is in the current state. So var update, and we're going to say var velocity is equal to move. And remember that turns the velocity after the move and slide. We can say that this is a vector2, which it's already implied that it is. So when we get the velocity after trying to move the character, if the velocity is 0, we don't want it to change state. But if it is moving, so we'll say if not, vector2.0 is equal approximately to the velocity, as long as the current velocity is not approximately 0. Then we'll send an event out to let the state machine know to switch states to the move state. So we can do that with the dispatch function. So dispatch, and I'm going to say moving in quotes here. You can pass in cargo to that event. So any data you might want the receiving state to know about based on this event change, you can pass that in. So I can send the velocity if I want. It's not really needed here, but you can do that. So we dispatch this. It's going to go up to the state machine. And then the state machine is going to determine what the next action should be. Now, right now, if we look at our state machine script, there's actually nothing here to create a transition between idle and move. So first, what I'm going to do up here is I'm going to create a dictionary. So var states dictionary, and this is going to connect a string name with the limbo state that it's actually trying to change. And then from that, I'm going to create a function. I'm going to call it binding setup. I underscored it to make it private, indicating it really is only used internally inside of this script. I'm going to add a transition from the state that's sending the event. So that's going to be states, and let's say in quotation mark, idle, to transition to states move when the moving event happens. So the event name is moving. Okay, now I click on this state machine. We have this dictionary to set up, and I want to put in the states and connect them to the limbo state. So the name, idle, we'll assign that to idle. Add key value pair. Next, move, and we'll assign that to the move state. Okay, so when it says states and then in quotations, idle here, that means it's going to get the key, which is a string defined up here, as in the idle string, and that connects us with the idle state. So this bit right here is actually getting the state itself, the limbo state, the idle state. And then we're transitioning from idle to the move state indicated by this key move. So I just think that's like a pretty clean way of having a reference to all of your states inside of a dictionary, and then being able to use them down here for binding everything up. So we also want to be able to go from moving to idle. So might as well add that transition now. So add transition. And we'll say states move, and then we're connecting that to states idle, and the event will say stopped, as in the character stopped moving. So we should be able to go into the move state now, but not back to idle. So let's hit play. Okay, looks like, oh, we have to remove that logic from the player character body 2D. So we're not actually moving here anymore. It's the state itself which is handling that. So make sure you remove that from your physics process on the root script. We're trying to break everything out from this logic into the state machine so that not everything's being controlled by one script. The state machine breaks apart your logic into different states so that each state can handle what should happen during that state. Okay, now hit play. And still got an error. Let me see here. Character stats equal agent stats. Okay, let me see here. So it's called player stats up here in the root script. So like, yeah, if you try to assign something that doesn't exist there, you're going to get an error. So I might just go up here and rename this to be stats. Okay, and then we just need stats.jump velocity down here, reassign the player stats. So quick load, player stats. And now when it's grabbing it inside of the character state, it should be able to see that. We could say character.stats here. Eventually, we might actually create a character class which extends character body 2D. And then that has it hard defined that it will have like stats and other properties. So if we hit play now, it should work fine. I'm going to WASD to move around. So we can see it's not actually switching states as far as we can tell. So let me check the errors. In idle state, let me see if this is actually dispatching. I'm going to set a breakpoint here and let's hit play and move around. Okay, so this is actually dispatching. So we hit play. I jump into the state machine. Oh, it's because I never called binding setup. So on ready, we want to bind the setup, obviously. So underscore binding setup, have this code actually execute. And then we'll hit play and WASD. So the breakpoint was hit. I'll hit play, and we can see that we get to the move state. And from the move state, we can't do anything because the move state doesn't actually have code yet. So just like with the idle state, I kind of want to copy this over to the move state script. So what I'm going to want to do here is say that if vector2.0 is equal to the velocity, so I'm going to get rid of this not, then I want to emit the stopped event. And then that will go back up to the state machine, where based on this transition, we can go back to idle. Okay, and also, obviously very important here, the update actually calls the move. So I'll hit play, WASD to move, and now we are switching between idle state, move state, and the animation switch whenever those actually enter. So that is handling the logic for idle to move state for our state machine. And as our character grows in complexity, has more states, some which will be able to move and some which won't, separating everything out into states will just make your life a lot easier, especially for these kind of platformer characters. So that's going to be it for this tutorial. I hope that has been a decent intro into hierarchical state machines, especially with Limbo AI specifically. And then after that, we will get to the behavior trees for the enemy, which will look quite a bit different simply because those are going to control logic, not through player input, but through decision-making code that you write for the behavior tree. So remember, you can get the files for this project in the description below, Ko-Fi and Patreon. I've been Chris. Thanks for watching, and I will see you guys in the next video.